Hi friends, see today I am starting a very easy chapter in second year, that is communication systems. So this is I think 15th chapter in second year, and this chapter is very small, and from this you are getting hardly 1 mark in MSET. Hardly, only 1 mark, less than 1 mark, 1 to less than 2 marks. Hardly you can say only 1 mark. Okay? Now first of all, in communication systems, first of all, what is communication system? So now I am talking here how this how this voice is reaching to you. So this is a process, very big process. Okay? So if my voice has to be heard by you, there is a long process. For this I am showing a block diagram, you can see on the board. This is the block diagram for communication system. That means how the voice from certain place it is received to the person. If you observe the block diagram here, you can see carefully. Information source and whatever speech is given in the studio or whatever song is rendered in the studio, that is in the form of information source. But this is in what form? Mechanical and electrical wave. It is what? It is having some pressure. So this wave cannot be heard directly. So this information source, whatever sound or speech given, it will be in the form of mechanical wave and electric wave. So for this it has to be transmitted. So it is transmitted by using a input transducer. It is sent by using a input transducer. So from this whatever song or whatever speech is given, it is transmitted. This electrical wave and mechanical wave. Now what is the function of a transmitter? Transmitter is also what happens, it is also called as a modulation. That means it attaches the electric wave and the carrier. That means it carries, what is transmitter? It carries the mechanical wave, the wave given by the sound or whatever song in the studio. So this electric wave or carrier wave, electric wave and carrier wave. And అర్థం ఏంటి ఇక్కడ, this wave is carried. Suppose ఇప్పుడు నేను ఇక్కడ మాట్లాడుతాను స్టూడియోలో. This voice, if I want to, you want to hear my voice, then what I have to shout little very loud. So instead of doing that one, what I am using input transducer and I am transmitting. I am carrying that wave. That is called as carrier wave. Whatever electrical wave. So this is called as modulation. And next what happens? Through channel. Channel and indicator, the sound whatever produced is sent by either different types of modes like sky waves, ground waves, by using optical fibers. Already I taught in you in the ray optics. So optical fiber lo em chestundi, total internal reflections, ante whatever speech is coming outside, it undergoes TIR and then it goes. And there you can see next one, receiver. Receiver function what? Receiver and this transmitter plays very important role. Receiver means it detaches the electric wave and carrier wave, and it is also called as demodulation. Receiver pani enti, it detaches the sound or whatever speech. It is called as demodulation. And finally you can see output transducer. From that, this mechanical or electrical wave, what was in the original form, that form is received to the receiver. So this is the entire block diagram of communication system. And whatever sound rendered in the studio, it undergoes so many waves. It is a mechanical and electrical wave. It goes from information source to input transducer, then transmitter modulates the electrical wave and carrier wave, then through channel by using some optical fibers. Okay, sound. Of course, noise will be there. This can be removed from the channel. And receiver, again it is demodulated. It is also detaching the sound, and again output transducer, and it receives for the receiver in the original form. Please note down this block diagram. It is very, very important. So this is the main block diagram in the communication of whatever sound or whatever picture in the studio. Okay? Right. Now let us go to the next one in this one. See, in this chapter already I am telling you, this chapter is very small chapter, only 1 mark is coming in MSET. So mainly important things I am dealing, because I told you in the beginning, regarding MSET point of view only I am considering the class here. So this is chapter number 15. Okay, according to the MSET syllabus only, we are going important things I am dealing, because this chapter is very small. Now, after learning about the block diagram, let us see the propagation of electromagnetic wave. Propagation of this EMW. That means whatever wave is rendered in the studio, in how many waves you can send those modes. One is by skywave method. Second one, you can say by ground wave, or you can take this one as a first and this one as second, and third one is by space waves. So we will detailedly study about what is ground wave method, propagation of EMW, electromagnetic wave, sky wave and space wave. Ground wave చూసినట్టుగైతే, for example, this is the surface of the earth. For example, this is one antenna placed here. This is one antenna, antenna 1. From this, the wave is sent. Suppose one more antenna is set here, somewhere over here. Second antenna. This is first antenna. This is second antenna. So these waves are reached from ground to ground. Whatever waves is sent by first antenna, directly avtala vaipu inko antenna untadi. So that antenna receives this one. Receives the whatever wave sent by the first antenna. This process is called as ground waves. Okay. Now let us see the second one, that is sky waves. Sky wave ఏమవుతుందంటే same. See here. Here antenna is there here, and we all know we have some layers above the at the surface. That is called the ionosphere. Ionosphere. So here the wave is sent to the sky, and again from that sky the wave again reached. In what fashion? Ionosphere lo reach అయిన the wave sent by the first antenna, it behaves like TER. Whatever the thing is happening in the optical fiber, you can see in optical fiber చెప్పాను కదా optics లో. In optical fiber, when the light is sent, it refracts and then again reflects continuously. So by this process, total internal reflection process, it reaches the ionosphere. Again from that it reflects continuously and reaches the receiver antenna. This is how the messages or whatever thing waves are done in sky waves. Okay. Now let us go to the third one. Third one, space. Third propagation, how the waves are propagated in third process. Third process lo em jarugundante, somewhere, not here, somewhere over other country you are, somewhere in America, and one is in India. Okay. So in such cases, what we will do in sky, okay, that is space. Okay, చెప్పాను కదా మీకు, ఒకటి గ్రౌండ్, ఓకే, ఇంకోటి ఏమో స్కై, ఇంకోటి స్పేస్. థర్డ్ వన్ ఇస్ స్పేస్ వేవ్స్. స్పేస్ వేవ్స్ ఏం చేస్తారంటే, బై విల్ బి యూజింగ్ ఏ శాటిలైట్. We'll be using a satellite. We all know what is the use of a satellite. In gravitation chapter I told you it is rotating continuously around the earth, and it will take pictures and send to the required position. So here one antenna will be there. From this the waves are sent, and from that side, whatever country, that waves are again reached to the other antenna. Okay, here one antenna, other one antenna, రెండు antennas ఉంటాయి. So waves are sent into the space. Satellite will be there. From the satellite, whatever photographs are there, whatever things are there, that is sent to the other country again. So in this fashion, space wave communication is sent. Okay. So three types of electromagnetic waves. One is ground waves, another one is sky waves, and third one is space waves. Okay. Now let us go to the next one. Let us go to the next one. In next process, if you see, after different types of modes of sending, next item is line of sight, LOS. So this is also called as line of sight. line of SIG is this side. So what is line of sight? For example, this is the earth surface. Okay. Now this is the antenna. So from this, if you see, if you draw a tangent, up to what distance it maximum, you can see. That means from your eyesight, that is line of sight. From your eyesight, if you see, because you know that is in curvature in shape, not flat, it is curvature. So at up to what distance you can see, at what distance you can, the range, that distance is called as line of sight. Okay, if you draw a tangent, this distance is called as line of sight on the earth surface. Now for this, we have one small equation also. I will try to give that one. Line of sight, the maximum range distance up to which you can see. దానికోసం ఏం చేస్తానంటే, for example, this is the earth surface. We will try to give that equation D. What is the distance? Line of sight. Distance or LOS, line of sight. So suppose this is the earth surface. Let us consider this is the radius R. Now suppose ఇక్కడ ఎక్కడో యాంటెనా ఉందనుకుందాం. Let this antenna placed at some height h. Okay. Let at a height h the antenna is placed. Now see here carefully. I'll draw a tangent, line of sight. This is the tangent. Now I'll drop a perpendicular here. Whenever you drop a perpendicular, it makes 90 degrees. Okay? And this is what? H. And this becomes hypotenuse. Total distance is R plus H, this one. And this is also again your radius. And this is the distance, line of sight. So if you observe carefully, this is a Pythagoras, opposite side. This is making some angle. Opposite side, adjacent side, hypotenuse. So from this figure you can see, by using Pythagoras theorem, R plus hypotenuse whole square is equal to adjacent plus opposite. Adjacent plus opposite. A plus B whole square. A square plus B square plus 2AB. Take this one, R square to this side. D square. R square get cancelled. H square plus 2RH under root is equal to D. But sometimes when this height is very less compared to the radius, we all know radius of the earth is 6,400 kilometers in kilometers, or in meters lo kavalante 6,410 cube meters. So large value. So when you compare this value, h square can be neglected. Therefore, root over 2RH. So this is the distance value or range. Up to how much range? Okay, that is 2 into radius of the earth into h. H is the height of the antenna. Okay, h is the height of this formula is very important in numericals while solving them. Suppose if he is asking you what is the height of the antenna required, R is given, D is given, or if you want D, H is given, you can substitute the value and you can calculate. Okay. In the same way, if you want one more antenna, the other side, ఇంకొక యాంటెన్నా ఇటు పక్క కావాలనుకోండి, for example like this. See, one antenna is here. Okay, you can call it as transmitting antenna, and another antenna is somewhere over here, second antenna. Antenna 2, receiving antenna. Same way you can again do. See, distance D1, distance D2. So same way, if you apply the formula here, you will be getting how much? This total distance, root over 2R H1 antenna 1 plus root over 2R H2. This is the total distance. Okay, this distance plus this distance. Already I have derived just now. That is what? 2 times radius into H1, height of the antenna. ఒక antenna height transmitting అనుకోండి, ఇంకోటి you can take it as receiving antenna. One is transmitting antenna, waves ఏదైతే పంపిస్తుందో అది transmission. ఇంకోటి R is receiving antenna, height height of the receiving antenna, height of the transmitting antenna. So like this you can calculate the values thereby. Very easy one. Clear? Right. Now this is about the story of the line of sight. Okay, formula, mathematical formula by using Pythagoras theorem. Now after this let us go to modulation of waves. See, generally wave modulations are three types: FM, AM, PM. FM means frequency modulations. FM means frequency modulation. AM means amplitude modulation. And last one is phase modulation. But in our syllabus we are having only this one: FM, PM. Phase modulation and frequency modulation is not there for our syllabus. We are having only amplitude modulation, please. Okay? Note down. Right? Now, just I spoke about the mechanical wave. So, how the wave is sent from the studio to the receiver. For example, we will try to understand in a better manner how the signal is sent, okay, message signal, and what is the graph for that one, and what is the mathematical equation, okay. దానికోసం నేను ఒక గ్రాఫ్ తయారు చేస్తాను మీకు. దట్ ఈస్ యాంప్లిట్యూడ్ మాడ్యులేషన్లో హౌ ద మెసేజ్ సిగ్నల్ ఈజ్ సెంట్. గ్రాఫ్, ఓకే, స్మాల్ గ్రాఫ్ ఫర్ message signal, carrier wave, and finally net wave. Carrier wave, okay. For example, let us consider y1 is given by am sin omega m t, first equation, first wave. This you can call it as message signal, okay. This is message signal. Second one, carrier. Sometimes this is also called as ym, yc, carrier wave. So a carrier, amplitude of the carrier, amplitude of the message, sin omega c t. These are the sine function equations for message signal, message amplitude, sine function, and omega m, frequency of the mechanical message signal, and WC and the frequency of the carrier. Please make a note, if anything is sent to the other place, the carrier frequency which should be more, very much more than the frequency of message. Then only it can reach faster. If anything has to be sent to the other place, the frequency which is taking the message or sound or whatever picture, this frequency should be very much greater than the message frequency, the carrier one. The carrier wave frequency should be more than the message frequency. Okay, please make a note of this one. This is very important. Okay, so these are the two waves. First we will see the graph and then we will go for the equation. Or first of all we will do the equation and then we can go for the graph. See, first one, x-axis time versus wave y-axis. This is what wave? This is message signal. This is message signal, and what is the wave here? You can see message signal y1 is equal to am sin omega m t. This is the equation. Same, coming to the this message carried by the carrier wave. So carrier wave enti carrier wave Y2C is equal to AC sine omega c t. As I said, this frequency is very much more than that message signal. The frequency, carrier wave frequency should be very much greater than the message signal. Appude the fast ga reach avutundi. Therefore, you can see it will be in this form. Frequency is more. So the graph will be in this fashion. Very nearer it will be. Okay. Clear? And the resultant of this, I think you can't see this one, I will draw it on the top or right side. The resultant of this, I will draw here. Resultant. Can I draw here the resultant of these two waves? Resultant I am drawing here, you can see, observe carefully. Y-axis. So resultant wave Y net. What is Y net here? We got, actually I will show you in the equation again. First of all, write down AC plus AM sine omega m t into sine omega c t. This is Y net, isn't it? That is the Y net equation, Y axis. This is time again, of course. Time. Y net into AC, that is carrier wave amplitude plus message signal AM sin omega t into sin omega c t, that is Y net equation. Yes, AC plus AM sin omega t into sin omega c t. So this is Y net. So if you observe carefully, then graph ఎలా వస్తుందో చూడండి ఒకసారి. It will be in this fashion. Maximum, minimum, positive side. And the same way, negative side also will have like this. I am rubbing this figure, please. Negative side also will have like this. Maximum, minimum. And the wave will be continuing. So this is the maximum. This is maximum. And this is minimum, please. This is minimum and this is maximum. And here you can see, here the graph will be like this. Please watch carefully. This is the graph for maximum, minimum, please. See here? So this is the graph for the message wave, message signal, and this is message signal. Okay? What is the equation? AM sin omega mt. This is the amplitude of message signal. And the carrier signal, I told you, the frequency is very much larger, carrier signal, because it has to reach the other place. So you can see this is the graph for time versus the equation. AC sin omega. And the resultant of this, you can see, maximum, positive side, negative side, and minimum value. Okay? And here also we have the maximum value and minimum value as AC plus AM. This value is AC plus AM, and this value, minimum value. This minimum value is how much? AC minus AM. That is amplitude of the carrier wave minus amplitude of the message signal. Amplitude of the carrier wave plus amplitude of the message signal. Maximum value and minimum value. AC plus AM, AC minus AM. Please note down, these are very, very, very important. AC plus AM and AC minus AM. Clear? Now I will give the equation. How to get that? How we got these two equations and other thing? Please copy this graph. This graph is very much important to understanding the message signal and carrier wave. Clear? Okay? I am rubbing the equation. Now I will try to give the mathematical equation for you. This is very, 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 very important to understand the message signal and carrier one. Okay? Now I will put this figure for you. Now I will show you how that equation we got. See, this was the first equation. Message 1, that is AM sin omega m t. The same fashion, second equation, that is carrier wave, A carrier sine omega c t. And I told you this frequency should be very much larger than message signal, otherwise it won't go to the other side. This frequency should be more. Now please make a note, I am not adding these by using principle of superposition like in light waves. I am not adding y1 plus y2. What I am doing, for y net, I am taking this signal amplitude AC carrier plus AM sine omega m into t into sine omega c t. Please make a note, I am not adding y1 plus y2 by using a principle of superposition, because the frequency of the carrier wave is more. So for that amplitude I am adding this one, AC plus AM sine omega m t into sine omega c t. Now you multiply this one, what you will get? Y net, when you multiply, you will get it as AC sine omega c t plus AM sine omega c t into sine omega m t. You can see this is the final equation we are getting after adding AC sine omega c t and AM sine omega c t sine omega m t. Now I will put this one as it is, AC sine omega c t plus this one. What I will do is I will multiply and divide with 2. I will multiply and divide with 2, and this will become 2 sine A sine B, trigonometry. 2 sine omega c t sine omega m t. So this is in the form of 2 sine A sine B, trigonometry. So cos c minus d minus cos c plus d. Okay, na? So this one I will write in this form, trigonometry form, 2 sine A sine B, cos c minus d minus cos c plus d, please. Okay, na? Plus 2 cos c minus d minus cos c plus d, trigonometry form. So రాసినట్టుగా I will get it as y net is equal to AC sine omega c t plus AM by 2. This one 2 sine is cos c minus d. Okay. So cos c minus d. C minus d, that is WC minus WM. Okay. WC minus WM you will be getting. We will write it here. C minus d. Yes. 2 cos c, that is WC minus cos c. This is C. And this is D. Okay. Cos c minus cos c minus d. Okay. T కూడా ఉంది కదా లోపల. Minus cos c plus d. Cos c plus d. See the entire equation? This entire, ఇది మొత్తం this one, cos c minus d. C minus d. Omega c t minus t common తీస్తాను ఇక్కడ. So WC minus WM minus WC plus WM. So this entire equation will change into this fashion, you can see. Message signal and carrier wave y net. Are you following here? So here if you observe carefully, you are having 3 frequencies. Frequency 1, WC. Frequency 2, that is omega c minus omega m. In the same way, frequency 3, third frequency. What is that one? Omega c plus omega m. So 3 frequencies are getting. One is omega c, one is little higher than omega c, upper, and one is little lower than omega c. Omega c minus omega m and omega c plus omega m. That is frequency of the carrier and frequency of the message signal. So 3 frequencies you are getting. Please watch carefully, please. Okay? Any doubts in this one? So WC plus WM is also called as side upper band. Side upper band. Side upper band. And this is called a side lower band, please. Side lower band. This is also called a side lower band. WC plus WM is called side upper band, and this is called a side lower band, please. Okay? Copy it? Right. I am rubbing the equation. Just for the sake of understanding, I am given this equation. Otherwise, I would have given direct equation for you. Why not? Okay? So, I am rubbing the entire equations here. So, this is how you have to understand the message signal and the carrier wave. And the omega C should be very much greater than omega m, please. Otherwise, the message won't reach to the other side. So, finally, you have learned the three frequencies are forming in this equation. One is frequency 1, WC. One is WC plus WM. Another is WC minus WM. Little higher, little lower. Higher. This is lower. Okay? So, those are the three frequencies. Side upper band, side lower band. Clear? Right. Now, let us go to the next one. We are coming to end now. This, as I told you, this chapter is a very small chapter. Hardly it is getting 1 mark in the examinations. Okay? So, that is why what all important only we are dealing here, please. Okay? Right. Now, coming to the last one. How to get power. Okay? And what is the minimum height of the antenna required or tower required? See, minimum height of the tower required. Examination you could adugutunnadu. Minimum height required HM is given by lambda by 4. That means height is directly proportional to wavelength. Lambda is wavelength. Also you know V is equal to n lambda, or V by lambda is equal to n. Adhodna V is equal to n lambda, or V by lambda is equal to n. So here you can observe frequency is inversely proportional to lambda. All these equations you can utilize in numericals. So minimum height of the tower required formula is wavelength by 4, lambda by 4, please. Note down this one, you will be using in numericals. Okay. Note down? Right. Now let us go to the power formula. What is power? Okay. Last we are coming in. See, power. Power generally is, you will be asking what is the power formula we know. We have different formula. VI, I square R, V square by R. Electricity will be having current density. Power is equal to V into I. And also, because what is power actually? Rate of doing electrical work. What is W? VQ by T. What is V? Ohm's law IR. What is Q? IT by T. See? So from this what? I square R, one formula. Another formula? I into R. Ohm's law VI. And what is another formula? P is equal to V square by R. Because same formula you can again change. The I square R ne you can change it. Elaga? V is equal to IR, or V by R is equal to what? I. Put it here. V by R whole square into R. That is equal to V square by R square into R. That is V square by R. So power is given by, in this formula, V whole square by R. Ikkada V and RMS. Root means square value. V RMS by R. R is resistance and V is RMS. And sometimes this is also written as in this fashion. Please note down. I will give another formula also. Sometimes the power formula is also written in this way. That is, sometimes power is power total. The examiner is asking power carrier wave plus power sideband. power sideband. This is the total power. Power carrier wave plus power sideband. So power total formula, please, I am telling you, it is mainly orientation for MSET bits only. Hardly it is coming 1 mark. So that's why I am giving directly the formulas here. So please note down. Power total is given by power carrier plus power sideband, and that is AC, amplitude of the carrier wave, by root 2 whole square into 1 by R is resistance of course, plus amplitude of the message signal by 2 root 2 whole square into 1 by R. This is the formula you will be using for numericals. Power, total power is equal to AC by, that means amplitude of the carrier wave by root 2 of course whole square into 1 by R, plus AM by 2 root 2 whole square. AM means amplitude of the message signal by 2 root 2 whole square into 1 by R. Okay, into 1 by R. This is the formula for power total. At times you can use for the numericals. Okay, right. Now sometimes you may ask the frequency formula also, please. Frequency, please note down. Frequency. Frequency means, for example, modulation signal. For example, detection of modulation signal. Modulation signal అంటే ఉదాహరణకి సపోజ్ దిస్ ఈజ్ 1, ఇక్కడ నుంచి మనకి సిగ్నల్ వస్తుంది, ఇక్కడ రీచ్ అవ్వాలి యాంటెన్నా నుంచి, యాంటెన్నా 1, యాంటెన్నా 2. దిస్ వేవ్ షుడ్ రీచ్ హియర్. సో అప్పుడు ఇక్కడ ఏంటి, సఫిషియంట్ ఫ్రీక్వెన్సీ ఉంటే కానీ రీచ్ అవ్వదు. సో వాట్ ఇస్ దట్ ఫార్ములా? ఫ్రీక్వెన్సీ ఈజ్ ఈక్వల్ టు 1 by 2 pi RMC. This is the formula for the frequency. That means if whatever waves are sent from one antenna to receive here, this is called detection. This is called a detection of modulation signal. Okay, detection of modulation signal. So our frequency ఎంత ఉండాలి ఇక్కడ? 1 by 2 pi constant or resistance. R is what? Resistance. M is modulation index. Modulation. This one already I told you, AC by AM or AM by AC, please. AM by AC. AM by AC. You know units because index is the amplitude of the message signal by amplitude of the carrier signal, please. Amplitude of the message signal by amplitude of carrier signal. AM by, this is modulation index. And C capacitance. C is capacitance in farads. So this formula you can utilize for detection of modulation signal frequency. What is the frequency formula? There you can use that one. Okay. Now almost we are coming to end ending. That's all. Sometimes if they are asking some percentage, okay, carrier wave percentage. If they ask you carrier wave percentage, then you have a formula for power carrier by power total into 100. Carrier wave percentage కావాలంటే power carrier by power total, already given in before formula. Okay, power carrier by power total into 100. అలాగే another one you are having power side, okay, side band by power total into 100. This is side percentage, side band percentage. If you want side band percentage, power side band by power total into 100. అలాగే carrier wave percentage కావాలంటే power carrier by power total, okay, into 100. So these are some extra formulas given for you, where PT is power total, already given the formula. Okay, so PC by PT into 100, అలాగే PS by PT into 100, side band percentage. Okay nandi. So very small chapter, I told you in the beginning only, very small chapter this is. Communication system, hardly you are getting 1 to 2 marks in MSET, please. So please study well what all graphs are given for you regarding the message signal, how the signal wave is going. Okay, next, why the frequency is more for the carrier 1 because it has to go faster. You can see the graph also. And finally Y net. Okay. Then for maximum and minimum. That maximum minimum value also I have given for you. That is in the graph AC plus AM and AC minus AM. You have three frequencies there. Omega C, AC plus AM, AC minus AM, please. Okay, clear? That's all about this chapter. Please study well. Again, we will be meeting in the next chapter.